So we have this question of swapping node in a linked list. This question is from LeetCode, and the question states that you are given the head of the linked list and an integer k. Now return the head of the linked list after swapping the value of kth node and from the beginning and kth node from the end. Now let's see the question simply says that we will be given this linked list 1, 2, 3, 4 and 5. Finally we'll have null, and and there is another value k will be given to us. Now what we need to do is we need to go to the second node and second last node, right? Second node and second last node, and we need to swap the values, right? So here we will have a 4 and here we will have 2. Now this question is really simple. All we have to do is to find this two node and assign two pointers. Let's say we have a pointer first assigned to it, and we somehow figure out to assign another pointer, let's say last, to it. All we'll do is swap the values, swap the data into this two pointer. We'll write three lines. The will be int data will be first dot val, then we'll have first val. We are storing for in first val, we are storing last val, right? The last value we are storing into first val, so last val, and finally we'll assign last val the data, right? This is a classic case of swapping two values using the third variable. You could have done using without the using third variable, but I had done it using third variable. All you have to write is this. Now first we need to figure out how to assign this first and last. Now for this, what we are going to do is we're going to find the pattern, right? Here we can clearly what if we could find the length of the linked list, right? Let's say we found out the length of the linked list, length to be 3, 4, 5, right? There we have length to be 5. Now the second node, we will iterate over this linked list once, and we'll go to, once we find out we are at the second node, we'll assign the first pointer to be pointing to this node. And what about the last? So if we observe, we could figure out and point out the last to this node by doing length will give us 5, length minus k, minus k is 2, length minus k will point us here, but we need to go over here, so length minus k plus 1 will successfully point the last node to this node, right? The required node, and then we can perform this simple operation to change the data in it. So the first part would be to find the length of linked list, and then assign first first and last pointer. Now finding the length is really simple. All we have to do is we have to make a new node, make a new pointer, let's say mover or move, and assign head into it, so we don't need to tamper with the head. And we'll do while move, or we can write while move is not equals to null. Both will fetch out the same result as in integer. Once the move approaches null will be treated as while 0, right? So while 0 is going to exit the while loop. So we could write while move or while move not equal to null, and perform length, set the length initially to 0, and do length plus plus, and shift the mover to the next node by move will be move is equal to move dot next, right? And this will give us this piece of code. Hold on. This piece of code will give us the length of the linked list. Now what we need to find out the kth node and length minus k plus 1th node, right? And assigned first pointer and last pointer to it. So simply we'll iterate again. So as we have moved these move pointer to the last, let's assign this move pointer to first head, right? And again run while move. Let's outside this while loop, let's define first first node to be null, right, and last node to be null, right? Now what we are going to do is we are going to maintain a counter, let's say counter to be 0 initially. Now every time this while loop runs, we'll increment the counter to counter plus plus, right? And we'll write two if statements. First if statement will be if counter is sometimes equal to k value, k will give us the first node, right? So the first node, if we get the k value, then what we are going to do is we are going to assign this assign the first pointer to the move. All right. Now if we find counter to be equal to length minus k plus 1, what we are going to do is assign last to move. Now there is an additional statement that you can write or cannot. If we write, it will decrease the time complexity. Like if we write if move if first is not equals to null and last is not equals to null, then break. Now I'll tell you why I wrote this statement. Right, this statement is not necessary actually. You could write this to decrease the time complexity. Right. Now these are the two main if statements that we need to execute. This will put the first pointer, assign the first pointer, and this will assign the last pointer to it. Now this is optional. What we'll do is initially what we did, initially we set the first and last to null, right? Initially we set the first pointer and last pointer to null. And if the first pointer is not null and last pointer is not null, then we know for the fact that first will be pointing to here and last will be pointing to here. So no need of iterating afterwards. Let's say we have other nodes like some other nodes, right? Then we don't need to iterate over the other parts, as we found out our first and last. So it will save some time actually. So we know how to calculate the length, right? We know how to assign the first and the last pointer. And once we find out, after that, we can simply execute this line, right? These three lines to change and swap the values. At the end, we will simply return the head of the linked list. And this will be our answer. We have the code for the problem. And the first thing that we did was to find out the length of the linked list. Now this is going to take a time complexity of on, assuming n to be the number of node in the linked list. Then what we had done is we ran another while loop, another while loop, and what we had done is we assigned the first and the last pointer to it. All right. Now assuming for the OS time complexity, the last pointer to be at the last node, it will take a time complexity of on. Now and at the end, what we had done is we have swapped the data. Now the code runs on an average time complexity of 2 times on. Let's look at the time constants. Now this is the most important part of the code. Like once you have the logic, the code is going to give us TLE or not we are going to understand from this section of the code, this section of the problem. As we can clearly see, the k and n value lies at the maximum of 10 raised to the power 5. Right now 10 raised to the power 5 is less than a million, 10 raised to the power 6, right? It lies in this range. So we can basically do o n log n, and o 2 times o n will also work, right? We can use two pointer, greedy, heap sort, etc. Now what if our constraint was 10 raised to the power 6? Then this code would have got us TLE, and we need to think of a better optimal solution. As we need to if our code was greater than 10 raised to the power 6, like if the constraint that we are given here was greater than 10 raised to the power 6, then we need to optimize this code. This code would have get us TLE. The code should have run by the time complexity of O log n to O1, right? So looking at the constraint is the most important part. Once you figure out the logic, that does not mean that the code will run.